Let's design Blackjack. But first, let's go over the background of the game Blackjack. It's a pretty popular casino game. Usually we have a deck of cards. These are the possible cards. Each card has a value. We have the 2, the 3, 4, 5, all the way up to 9. And we do also have a 10 here, but the interesting thing is that a Jack, King, and Queen also have a value of 10. And the Ace is even more interesting. It can have either a value of 1 or a value of 11, whatever is more beneficial to the person holding it. And each of these cards, we have 13 of them, will have 4 copies of each of the cards. So usually the deck has 52 cards in it. And by 4 copies of the same card, we mean that we have the same card in 4 different suits, which could either be a diamond, a club, a heart, or a spade. But the main rules are pretty simple. Usually there are 2 people. One is the dealer. Usually they work for the casino. They draw 2 cards at the beginning of the round. And we also have a player. We could have multiple players, but for this, let's assume we have a single one. And at the beginning of the round, they also draw 2 cards. I believe one of the dealer's cards is visible to the player and one of them is hidden, but I think both of the player's cards are visible to the dealer. And ultimately, the goal for the player is to get as close to the value 21 as possible. So with their 2 initial cards, they can either make a choice. They can either draw another card from the deck or they can stop drawing. Of course, if let's say they drew an ace and a 10, then they would automatically have 21 because they would, of course, choose for the ace to be a value of 11, not a value of 1. That would mean their total hand is worth 21. At this point, of course, they're not going to draw anymore because they have the maximum value. But maybe instead they have a 10 and they have a 2. Then their hand would be worth 12. They can choose to keep drawing, or it's possible that they might draw a card like a jack, in which case they would add 10 to their total, and then their total hand would be worth 22. And they would go over 21. If they go over 21, they automatically lose. Now, let's say they got to the value 17. Then the dealer is going to draw until they pass what the player got. If the dealer ends up with the same value as the player, then the round ends in a draw. This is a pretty oversimplified view of blackjack. There can be a lot more nuanced and complicated rules, but I think for the purpose of this design, we are going to choose to keep it simple. This isn't a test of how well somebody knows blackjack. It's a test of how we can design it. So before we get into our design, what types of questions, let's assume you know the basics of blackjack or that your interviewer explained some of the basics to you. What types of clarifying questions could you ask the interviewer? Well, how many cards are in a deck? That might be one question you have. What are their values? Like what kinds of cards are there? Or maybe how many decks do we have? Do we just have a single deck or do we just have one deck? Are we going to refill the deck after every round? What happens if we run out of cards in the deck? How many players do we have? The way I said it, we have one dealer and one player. Is that actually going to be the case? Are we going to be implementing any type of scorekeeping or gambling mechanism? Because that's kind of what blackjack is about. And let's say that the answers to these questions are yes, we are implementing gambling. For the cards, we are going to have just a standard deck of 52 cards, just like I described, 4 copies of every card, 1 for each suit. The values are going to be just as I said. We're just going to have a single deck, which we are going to refill after every round, and we are going to shuffle that deck before every round. It's not like we're going to be trying the exact same cards each time in the exact same order. So we do need to shuffle that deck, and we are just going to have 2 players, the dealer and a single player who is going to be the one actually like playing the game. In terms of the gambling mechanism, we're going to keep it simple. The player can wager any amount that they want, and we assume that the dealer has enough because they work for the casino. So of course they should have enough money. And if the player wins, they get to keep their money and they get the same amount that they gambled from the dealer. If they lose, then they lose the amount that they wagered. And if it ends in a draw, they get their money back, but they don't win any additional money. Now, how do we want to implement the dealer? To keep it simple, we're going to make them pretty good in that they're going to play about as best as they can, which is that they're going to know exactly what value the player has in their hand. And the dealer, after the player goes, the player is going to go first. their turn is going to be first, and then the dealer is going to keep drawing cards until they go over 21, which of course then they would lose, or they reach or exceed the value that the player has. So if the player has 17 in their hand, the dealer is going to keep drawing until they get to greater than or equal to the value 17. So now let's talk about the high level design, and then we'll take a look at the code. So we know one of the important parts is definitely going to be the deck, and the deck is going to be made up of 52 cards. How exactly are we going to represent a card? Well, there's a few parts to a card. The most important and probably the only thing that we care about is the value of every single card. At least for the purpose of our design, maybe if we were making a graphical user interface, we would care about the suit of the card. We would care about not just the value, because we know 10 could mean 4 different things. So we'd also want to know like the unique ID of the card, whether it's like an actual 10, a jack, a king, a queen, etc. But that stuff isn't really relevant in our case. So the simplest way for us to represent cards is not even create a card class, just to have a deck of 52 values where the values will go from 1 through 9, and then we'll have 4 copies of the value 10. These are 13 cards, and then we'd create 4 copies of this, which would give us the 52 cards. Though to make this a bit extensible, I am actually going to create a card class, but I think it would be worth talking to your interviewer. I think most likely they would want you to create a card class because it seems like a very logical thing to do. But I don't know how much detail you'd actually have to fit in. I don't know, would you actually have to distinguish between a jack and a king? Because it doesn't really make any difference in this problem, but it might make our design extensible. Or maybe you could just talk about how you would do that, but you don't actually have to implement that. And if we are going to distinguish between the suits, how would we have represented a suit? Well, the logical thing to do is an enum, because there's 4 different types of suits. As I mentioned, there is the club, there is the diamond, the hearts, and the spades. So 4 different types. Now, another important part is not just the deck, but there is also this concept of a hand that will belong to a player. So a player will have a hand, but a player could be 2 different types. We could have a actual like user player. We know there's only going to be one of those, or we could have a dealer, and we also know there's only going to be one of those. Why do we need 2 separate classes for these? Well, they're both players, so each of them is going to make a move, but how they make the move could be different. For example, the user, maybe for the user player, we're actually just going to read user input. That's how we're going to implement this make move method. But the dealer will have separate logic for making a move. So maybe we can make this player either an interface or an abstract class, because we know that they are going to have a hand. So they are going to have like a data field, but they are not going to have this make move filled in. So this is going to be an unfilled method, and then these 2 will actually implement or override that method. Also, don't forget that our deck is actually going to have additional functionality. We probably want to be able to draw cards from that deck. We want to be able to shuffle that deck, maybe even refill that deck, or we could just instantiate a new instance if we wanted to refill a deck. That probably makes more sense. Now, the user player will probably have additional functionality in that they can actually place a bet, whereas the dealer can't. That also is another reason that these are going to be subclasses, because they are going to have different functionality. At a high level, this mostly makes sense. Now, the last thing is putting it all together, which we can do, let's say, in a game round class, because each round will have like some life cycle until the round is over. Either it ends in a win for the player, a draw, or a loss. And once we have that result, the game round is over. We can choose to play another game round, or we can't. Probably depends on how much money the player has left. If they don't have any money left, they probably can't play. And if they do, maybe they decide to continue playing, or we could just get some user input to see if they want to continue playing. That part probably isn't a super big deal. But what type of functionality does the game round need to actually implement? Well, we need to be able to play a round. So within our play method, we're going to do all of that. But what is this game round going to be composed of? Well, it's going to have a dealer which it probably can instantiate itself, or we can just pass one in. Same with a player, we can either pass it in or just instantiate a player within the game round. Probably for the player, we definitely want to pass it in, and probably the same with a dealer, because maybe we have a list of dealers and we just pick whichever dealer is available and we assign them to a player and then pass both of those into a game round. That seems like a pretty extensible way to code this up. We could also pass in a deck into the game round. That logically makes sense. The game round could instantiate its own deck, but I think usually passing things in as parameters when possible makes a bit more sense. Since we know this game round is gonna only play a single round, we know that the next round is gonna have a new deck passed into it, so we don't even have to worry about refilling the deck actually. At a high level, that is about it. You most likely wouldn't have time to code everything up in a real interview because it's going to be quite a bit of code, as I'll show you right now. But I think as long as you can understand the high level and how the classes and objects interact with each other, that's the important thing. And maybe your interviewer would ask you to fill in like one or two really important methods. But now let's take a look at the code. So as I said, we could have an enum for the suit. We could also have an enum for like the type of card it is, like whether it's a real 10 or maybe it's a jack or a king or a queen. It doesn't really matter for our design because we don't have a graphical user interface. But if we were trying to prioritize for that, we would probably want to be able to distinguish between which types of cards are they, not just the value of the card, if we wanted to display the card and the image to a user. We will also have a class for the card, though this is also pretty optional for this problem. It's mainly used to encapsulate information about the card, the most important being the value, but if we also wanted to encapsulate the suit, or like whether it's a jack, king, queen, ace, that could also be another data variable. Now for the deck itself, we know the deck is going to be made up of a bunch of cards, and when we instantiate a new deck, we know a standard deck is always going to be the same. It's going to have 52 cards. So we can just loop through 13 times for each suit and then create a new card using that suit and the value. Now, what happens if we're going from 1 through 13 here? 1 is going to be the ace in this case, which we know can either be a value of 1 or 11, so we will have to handle that somewhere. But what happens when we go through 11, 12, 13? Well, we're just going to take the minimum of the value and the 10. This is an easy way to do this because we'll have 4 copies of a 10. We could print the deck. I don't think it's super necessary in this case, but what is necessary is being able to shuffle a deck, which we're just doing by, for every card, we are generating a random integer between 0 and 51 and then placing that card at that index. We're just putting it in a random position for every single card. We're doing that. And we're also drawing a card, which is as simple as popping from the list of cards. Now, for the hand, we know that a hand has a bunch of cards possibly, but also it has a score, and that's the most important part. Every time we add a card to a hand, we want to update the score, and then we're printing it just for convenience. But updating the score is pretty easy. We just get the card value and add it to the score if we go over, but we know that there's a special case. What if the card value is 1? In that case, we would add 11 if adding 11 does not cause us to go over. But if it does cause us to go over, then we're just going to add 1. We're being greedy here. We're trying to add the maximum value possible, but if we can't, we default to the lower value. Then we have a getter for returning the score, a getter for returning the cards, and a convenience method for just printing the cards along with their suit. But this might have been better to be placed in a different class because we have a lot of printing going on. But this is mainly for convenience. This entire code, once it's complete, will run, so you can test it out yourself and maybe make modifications if you want. Now, we're also going to have a player abstract class. Now, the way I've coded this up, this isn't like an official abstract class in Python. If we wanted to do that, we would do something like this, where we actually declare this as it being an abstract class. And then this method, the make move method, we know that's what's actually going to be the abstract method. We would add the annotation abstract method. But otherwise, it's a simple class. We are given a hand that is provided to the player. The player is, of course, not responsible for building their own hand. They're going to be drawing cards, and then those cards are going to be passed in via add card method. We're also going to be able to clear the hand, like discard all of the cards, and also make a move, which we haven't implemented yet because it's going to be a bit different for each player. So For the user player, we know they're not only going to have a hand, but they're also going to have a balance. So we call the super constructor, the player constructor, on the hand, and we initialize the balance. We're able to get the balance. We also have a place bet method where the amount is passed in and it is decremented from the user's balance. We also have receive winnings where we will add an amount to the user's balance. And we have a make move method. This is kind of the important part. Just for simplicity, I'm just reading user input directly within this method, though logically it might be better to have that in a separate class that's dedicated to reading user input, or maybe even in the game class. We do have some logic here to make sure that the user doesn't make a move if their score is already over 21, because at that point, of course, they can't keep drawing cards. And this type of logic would make sense to not go inside of the user player. The user player should not necessarily need to know the rules, but I have it here just to not overcomplicate our design and not to make a bunch of extra classes. But it's up to you, and I think that's definitely a point that's worth discussing with your interviewer. And now we also have the dealer, which is going to be a bit more simple. They're going to have a target score. That is going to be the score that determines when they stop drawing. Now, we know we don't want to make it a hard-coded value. Sometimes in Blackjack it is, but in our case, we want to be able to update that target score because we want it to be whatever the user player drew. Let's say our casino is a bit sketchy, so they're just going to automatically know what value the user has, and they're going to keep drawing until they pass that value. Or, of course, they end up going over 21. And lastly, we're going to have our actual game round class, which we're going to initialize with a player, a dealer, and a deck. We're going to be able to read a bet amount from the user. So we're actually reading user input from this class this time, being a bit inconsistent. And I'll skip to the play method where we are going to be shuffling the deck. We're going to make sure that the user has money before we continue. This is some validation logic we have, which probably wouldn't be necessary in an interview. Maybe you could just talk this through. We're going to be getting a bet from the user, then placing that bet amount, dealing the initial cards, which is just going to iterate through twice, dealing cards to the player and dealing cards to the dealer. We're printing a bunch of stuff, which is just for convenience when you run the code locally if you choose to, but probably this wouldn't be necessary in a real interview. Then we have the user make a move. We draw cards until the user decides to stop. Then we check, have they gone over 21, in which case they lose automatically and the round is over. Otherwise, the dealer makes a move. And then after the dealer is done, we determine who the winner is. If the player wins, they receive winnings. If they lose, then they don't get their money back. And if the game ends in a draw, they get their money back, but they don't win any additional money where they got twice as much as they bet. And then after that, we clean up the round. By cleaning up the round, we mean just clearing the hand of both players. And we could run this code by creating a player with an initial amount of money, let's say 1,000. They have an empty hand, and the dealer also has an empty hand. And we keep playing until the user's balance goes under 0 or equals 0. We just create a new instance of the game round and then play around with a brand new deck. So that's the code at a high level. Like I said, it does run so you can play around with it. I encourage you to write your own variation. I encourage you to try different things, different ways to represent the cards. Maybe make your design even more involved than we did. Maybe we do want to distinguish between jacks and kings. Try to do anything that gets your mind moving about different trade-offs we could make and how they would affect our design if we were to continue coding this and adding features to it, or maybe adding additional players to it and things of that nature.